Welcome, everybody. I'm super excited to have you at today's Isaac Robotics Office Hours. We are covering a super exciting and timely topic, NVIDIA Brev, and how you can leverage Brev to make it really easy to run Isaac Sim and Isaac Lab. Really powerful frameworks for robotic simulation, training, and learning on NVIDIA Omniverse. You'll be able to leverage that directly on cloud GPUs with an automated setup. We're going to show you all that and more in this hour. Before we begin, I want to share some exciting news. We just announced this yesterday. And as you can see, I brought my very special guest, Sumay, here from the NVIDIA Inception team. An amazing contest with a huge prize pool attached for developers out there. Sumay, thank you so much for joining us today.
Thanks for having me on, Edmar. Really excited to talk a bit about the program that we're hosting, the awards.
I'm super excited to learn more about it. So we just announced this yesterday. So what's this all about, and who's eligible to join?
Yeah, absolutely. So just starting at a high level, Nebius is a NVIDIA cloud partner, primarily hosting GPUs. They are a complementary or alternative to our CSP partners as well. Nebius is partnering with us on an effort for Physical AI Awards. And the goal of the Physical AI Awards is to bring together multi-stage startups, primarily together to focus on an award ceremony and program that allows the startup to get an access or receive up to 100K credits as the finalist for the award program.
Absolutely amazing. And I see here you have some pretty good categories.
Yes, absolutely. So, this directly aligns with how we focus on physical AI and Nebius as well, putting our heads together. And so quickly going over these categories, Edmar, we're looking to work with companies that are focused on foundational models and robot brains or general purpose robotics, data engines and simulation that help drive synthetic data for a lot of these robotics applications and physical AI applications, in addition to those industrialized, verticalized robotic deployments that happen for maybe it's manufacturing or warehouse automation, along with vision AI, smart cities, and streaming video analytics that is tied into our Metropolis platform. In addition to platforms that are benchmarking, visualizing, and evaluating the data and the models as they're testing as well. Again, all covered around physical AI.
Amazing, such a diverse set of technologies there. Look at these prizes. So not only cloud credits, but introductions to VCs.
Yeah, absolutely. So, I think the big thing that I'd like to highlight here is, what's in it for the startup, and then of course, a little bit of what's in it for NVIDIA. More importantly, for the startup, one is the prize that you get around 100K credits through Nebius as well. In addition to the 100K credits, we're taking it a step deeper, which is you'll get access to media exposure and promotion if you're a finalist for the awards that we'll get into in the program timeline in a second, in addition to VCs, and then exclusive access to potential executive membership through some of the execs within the Nebius organization as well. This is a great way, one, to spotlight companies that are focusing on breakthrough technology across the 5 technology pillars that we spoke about, but also gets them deeper into the ecosystems through NVIDIA and Nebius as well.
That's fantastic. Okay, so, and it looks like the timeline here. So we're looking at applications opening now or shortly?
Yes, yes. So applications have just launched yesterday officially, along with all of our press release as well. Again, if you are a multi-stage company, not just early stage, that is focused in those 5 core buckets of technology, we'd love to have you apply. Link is in this landing page here as well. In addition to that, those rolling applications will close October 20th. And then from there, we have a set of panelists and judges, including myself, that will be evaluating across the 5 buckets as well for the startups that are in there. And then we will then finalize the finalists for the award ceremony November 3rd, going into December 9th, which will be hosted at the Computer History Museum in Mountain View as well.
Amazing, and it's a global kind of awards, but there's limitations for people need to be from the United States, Europe, UK, and Asia, correct?
That is correct. So definitely global. I'm glad you brought that up. Definitely if you are a finalist, we'd love to have you there. We think that 100K credits plus the exposure to the NVIDIA and the Nebius ecosystem definitely merits the travel. But of course, if you are stateside as well, and if you're a finalist, it'd be very good to have you there.
Amazing. I'll put the timeline on screen once again. And for our community watch, people who are watching this, let's give them a little inside tip. What will you be looking at as one of the judges?
Yeah, so I'll be covering. So the judging committee here, we're still uploading the images of the amazing judges that we have. Most of them are from our robotics leadership, if not all of them, including Metropolis. So they will be the more important faces on screen, I'd say. But I'll be judging across all 5 to 6 of the categories that we went over earlier. In addition to really focusing as well on the platforms that are benchmarking visualization and evaluation as well.
Amazing. Well, I can't thank you enough for coming on last minute and sharing with us with our community. I hopefully we get a lot of people to jump on because of your great presentation here. So thank you, Samay. I really appreciate it.
Thanks for your time, Edmore. Appreciate you bringing me on.
Thank you. Bye.
Bye.
All right. So now I hope as many people out there can join as possible. I think it will be an amazing experience for those teams and the winners especially. But speaking of winners, look who I've got here. I've got one winner, Shane. I got 2 winners here.
What did I do?
How are you guys doing?
Good.
Not bad.
Good.
How are you, Edmar?
Good. We have a very exciting episode today. I've got to say this is one of the hottest topics that we've seen shared lately. Actually, I'm going to take this off the screen for a second, just so that we can really focus on your lovely faces here as we go about this. But in the past few weeks, we've had several people in the community. We got Michael Wagner and also Shane. You've been producing some great contents celebrating the fact that you can leverage Brev for an Isaac Sim and Isaac Lab experience, and we're calling that a launchable, right?
Yeah, so Brev allows you to get really easy access to cloud resources for all kinds of AI projects. And launchables are ways for you to make like a template of what compute you're using, what files are on the machine, and really set up like an environment to work with. And then you can actually share that with others or not. In our case, we have one to share with you. But it's like a pre-set up way to work with resources, which has a ton of interesting applications, which we're going to talk about and show some of them off, and hopefully like inspire people to try it out for yourself, or maybe you have new ideas of how to use that we haven't even thought of. So hoping it's really like a jumping off point for other projects.
That's amazing. Okay, cool. We have a lot of people watching live. I can see the numbers climbing up by the second. So super exciting. So we're gonna so the next 45 minutes or so, Shane is going to kind of talk a little bit more what Brev is and what Launchable is, and we're gonna he's gonna do a show and tell. Then he'll kind of dive into the code a little bit, and we're gonna take your questions throughout the live stream. Anything that we don't pause that when you ask your question, don't worry. We'll try to get back to those at the end. So stay tuned. And we're going to cover general news. We have GTC coming up in Washington, D.C. At the end of October. Our CGRAS sessions also are now available for replay on demand. We'll talk about that stuff at the tail end of the live stream. So stay tuned after we cover the great topic for today if you want to learn more about GTC DC and our CGRAS sessions. But first, let's start by giving a brief introduction for my great guest here. So Shane, why don't you kick things off? Tell me about like what your role is at NVIDIA and why you're here today specifically.
Yeah, so I'm a technical marketing engineer at NVIDIA, and I focus on learning content. So making courses and educational materials. If you've ever been to GTC and taken a live robotics workshop, we work on all those. So I get this fun mixture of learning all the latest robotics tools we have and then trying to make them as accessible as possible. Try to take all this wide variety of applications we have and try to make it more accessible. Yeah.
Amazing. Well, you're doing a fantastic job by looking at all your great posts on LinkedIn. People should absolutely follow Shane's page. I'll post a link in the chat in a second. My other very special guest, a veteran of the live streams, hosting office hours regularly. Rishab, thank you so much for joining.
Thanks, Edmar. Thanks for having me here. I think
And,
in terms of quick intro, yeah, I'm a
Yeah.
tech marketing engineer as well, focusing mainly on robotic simulation. So Isaac Sim, a little bit of Isaac Lab as well. Got exposure to deploying onto real robots, so Jetson there too. And in general, I just really enjoy working with most of the stack in robotics, like from simulation to deployment to sensor debugging as well. If you actually have done it on real robots, it is pretty fun. So yeah, it's cross team working with Shane, helping build out technical learning materials, for example, also building sample workflows, reference architecture. So it's fun, and I also do get to talk to the community as well. Like, so I really do enjoy this.
Oh, well, we're very grateful for both of you guys making time to come on today to talk about this. And so now everyone watching in the community, now that you know a little bit about Shane's and Rishab's background, feel free to start posting questions related to their backgrounds and, of course, the topic for today. So with that, Shane, I'm gonna pass the microphone over to you. I'm super excited to see what you got to show today.
Yeah, if you wouldn't mind, we'll go ahead and show the screen share I have up here.
Here we go.
Oh, not that one. No, don't give that away yet.
All right. Sorry. Sorry. Look away, everybody.
Oh, surprise! I already screenshotted that. You get an early access.
Nope, cannot pause that.
We'll get to that. But for my engineers in the chat, I love to see the demo first, right? I love seeing that right away. So I'm just going to jump right to that, and then we're going to roll it back and explain how to do this yourself. So you might notice that I'm on a Mac right now, and I have VS Code, and you might be like, well, that's neat, Shane, but why do I care about that? Well, we're in Chrome accessing an instance of VS Code that has Isaac Lab pre-installed in it. And if I go to this URL/viewer, I have the entire UI of Isaac Sim available here, and I am testing out a policy I trained. So on a Mac, which usually you wouldn't use with Isaac Lab, and this was all pre-configured via a launchable. So this is our project. And I'm going to walk back and explain what all this is, but I just want to give you the 10-second version, right? Sorry, 1-minute version, let's be honest. So this is a public repo. You can go check this out right now. And this is a collection of containers and a project that you can run on Brev or even locally. We'll get to that just by clicking this button. And if you go to Brev, this is what the Brev interface looks like, and hit deploy and do one more click, then you would be here. And just to show you, while we're working, I sort of have this one already up and running. Let's go ahead and deploy this one. So I'm going to show you what the process looks like. But the big thing here is we have Isaac Lab running, and I did ostensibly 2 to 3 clicks. So again, back to the goal of like, how do we make this tool super accessible? If you want to learn Isaac Lab, we want you to get in and use the tool as soon as possible, right? Like how little installation can we set up for you to try this, right? So here we go. Here's a dev environment. Here's a viewer. If you run a command like a training command that doesn't need a viewport or doesn't need this is really more than the viewport, right? This is the whole Isaac Sim UI. Just to show you like all these menus, you saw me scrolling around in the viewport. This is the entirety of Isaac Sim. You can just run headless, right? So let's just do a few things here. And I can start to answer some questions if we see anything pop up, Edmar.
We do actually, right away. So super exciting. Cool. All right, so Jan is asking, I'll put this up on the screen. How about other Omniverse versions?
That's a great question, and we are working on that. There's going to be a version of this that's set up with the Kit app template. So that'll be another option.
Very cool. We got another one here from Armand coming from YouTube. Thanks for joining, Armand. What would you say are the main differences between Brev's launchable and the WebRTC version of Isaac Sim?
Good question. So they're super related, right? We're running Isaac Sim here. In fact, in this command, I'm just going to run normal Isaac Sim. So we let this run, we wait, and then once it says app ready, we'll go back to our viewer and refresh it, and we will see Isaac Sim. It takes like 5 seconds. And this is using WebRTC. So this is Kit app streaming as the technology underneath this. It's part of Omniverse, right? This is what's providing this stream to this URL. And this is really the part of this launchable that's really new. Like we're using Isaac Lab's container. If you're familiar with Docker, there's an Isaac Lab container publicly available. And this is using that. But what's really unique is that you have this embedded viewer that's all part of the same launchable. And you just have to visit that URL/viewer. So as you know, if you're working in Isaac Lab, you're going to be iterating and training your robot, evaluating, doing all these things. And this just gives you like a quick way to leave this tab open and keep working. I see some more questions. Yeah. So Armand, hopefully that answers your question.
Yeah, another quick point to like what Shane just said is also that just comparing like a Brev launchable with the WebRTC itself is like, if you do want to set up Isaac Sim on a public cloud or like even a cloud of your choice, like if you have a company or you've got a data center where you want to deploy Sim, you need to follow basically all the steps, right? You need to make sure all the configurations are set up, you've got the right hardware, pull in the Docker container, and then make sure things run, and then you probably set up your WebRTC viewer on your local client, which could be your workstation. So I think the fundamental difference there is, like Shane showed, that in Brev itself, you've got the viewer entirely embedded. So you have direct access to the GUI there, whereas on a different way where you actually set up everything on a CSP yourself, you're going to go through a lot more steps, and it's going to be a different experience. So it really highlights that here it's going to be a few clicks for you, and it's going to be very easy to get started and actually iterate through things, whereas taking that route, for example, may be a longer way. So fundamentally not very different, but just in terms of experiences, it's going to be quite different.
Very
Yeah.
good. Very helpful. All right, we're getting a bunch of other. Oh, go ahead, Shane. Go ahead.
Sure. I'll just say, while we answer other questions, I'll show you. We're running a training task right now. So, for example, we don't need the viewer. If I refresh it, nothing's going to happen. But we can let this train. This is the one that I trained earlier, and we saw it going. So let's let that cook. We're at 5%. Looks like it'll take about 16 minutes. We might kill that one and come back to something else. And then just to show you our other launchable that's deploying, if we go. So again, kind of going out of order here. Like originally, you go to our GitHub repo, you click on deploy, you end up on the Brev page, you've got some credits, you deploy, and now you're here waiting. And basically you want these three to be green. Then you get a link down here to launch your launchable. And then you're here. So we'll let this go. This usually takes about 7 minutes in my experience with the compute we chose and everything else. You get logs for different parts of the process to tell you what's happening. You'd see like, we've got one green check. So we'll check back on this. Just want to show you like the whole process, but also not make everyone sit for 7 minutes. So back to here. Let's just watch this exciting progress bar and answer another question maybe.
Okay, cool.
Maybe we can put this down for a minute if you want, Edmar.
All right, so we've got, let me see, I'll bring this back over here. All right, so we've got a question. Seems a simple, neat way to start Isaac Lab with zero ground, but little worried about security. Is Brev support long-lasting session?
I'm not sure what long-lasting session means, to be honest. And I'm also not a security expert. So
maybe if you want to clarify that in the comments, we'll circle back to this.
Yeah. Also, I see a comment about zooming and the text size. So sorry about the monitor. Luckily, the text on the screen, I'll try to talk through it and point things out. I've got the wide screen here. So apologize to anybody on a normal aspect ratio screen.
I'm guessing Brev, the question here maybe Shane about Brev is like in general, do we know like how long of a training job, for example, you could run on Brev? Like, is it straightforward to do that? Or like if I want to train for like more than a couple of hours, maybe like I just got one compute instance. So is it straightforward or not?
Yeah, like how long, how secure is your instance in terms of access, like availability rather, like how available is it? I haven't tested the upper limits of that. I have definitely run an instance for several days, and once you have it fired up, I believe you have a certain amount of, you own that instance for that time basically. If you stop it, so let's go back actually. Once this is up and running, just 1 second here.
I'm sharing your screen again.
Yeah. So once this is up and running, you can actually stop it and restart it. I saw a comment in the chat too about not being able to stop and restart. We'll get to when that happens, but with this launchable, you can start and stop it. When you stop it, it's possible that GPU will get used for something else. So it does make it cheaper, and you can kind of come back to where you were in terms of like you have your same environment, but you don't have like a reservation on that GPU while you're stopped. So I've only ever had to happen to me once that there was low availability, but that can happen, right?
So all your work is basically saved. You can come back and leave as you wish.
Yeah, and now if I stop it while this command is running, you'd need to start that training over. But you don't need to leave this tab open, right? This is just a viewport to VS Code. Like this process is still running in the background, and just to show that, like, if I, close out and come back, that's going to keep running. Maybe that sounds obvious, but just to point out, like, you can come back to it.
That's great. Okay, cool. Jen's asking another question here. How do I get my data USD on there? Nucleus or?
Great question. So if your assets are on a GitHub repo or on Hugging Face or something else, like you could do it through the terminal. But also this VS Code container makes it really easy. Like I'll just download this README as an example. Right click, download. And to upload something, I didn't prepare something good to upload. Let me find something quick. I'm just going to put a picture here of something. And so you'll
drag and drop.
see, there you go, drag and drop. The only little detail I'd say is if you can shift select multiple files, like if I do this, I can download those. If it's a folder though, I think you would need to zip that up like with a terminal command.
Yeah,
So
makes sense. And I think also apart from like locally uploading files, maybe if you've got it hosted on a public available S3 bucket, for example, or even a private one, you've got like direct terminal access into your instance. So you should be able to pull in whatever assets you've got and data you have from whichever source, as long as even like, for example, from your workstation or from wherever you're at, you're able to pull those assets. And so you could also be pulling it from GitHub, like Shin mentioned. You could be pulling it directly from there through the terminal or from other publicly hosted asset locations. So it should be straightforward. And Nucleus always is an option too.
Yeah, good points. So I'll show one more demo here, just to show something a little more interactive. That training was, that's going to take a while, so we'll let that go. That's the same task I trained earlier. Let's just do something a little more interactive and also show you how you can use some other tools like TensorBoard inside of this container that you might use in Isaac Lab or be used to using. So if I go back and refresh, this is a fun demo. If I can click accurately enough, you can actually pilot this humanoid around. So I'm turning right. So I'm like evaluating this policy, doing a form of teleoperation. And I mean, this could be video game of the year, to be honest. Like this is really fun. And it is really impressive though, right? Like look at how this policy can behave over that really, really wild terrain. So this is just showing some more interaction, right? Like I'm using my keyboard. You can't see that, but I was using my keyboard to control this. And then let's show you one more thing. Let's see. And feel free to interrupt me with questions. I've just got a couple more things to show here, and then we'll talk about our surprise that we teased, and then get into some more details for devs on like how to do more with this than what I showed you today.
Amazing.
So I've just run this command to look at logs from my earlier training session using TensorBoard. You can see when I ran it, I got this neat little shortcut to open in browser. And excuse me. Now we have a lot of different data about how our training went. Loss functions, policy, the rewards. I won't go into all these details, but like this is a tool that comes with Isaac Lab that actually adapts to this environment really well. It's really easy to use. So I think that's mostly it for things I wanted to show, right? Like here's Isaac Sim by itself, because of course Isaac Lab is built on Isaac Sim. So you get Isaac Sim for free, we'll say. You get it along with Isaac Lab. We trained a policy. Granted, I had kind of pre-trained it before we came on here. And then we tested it. And then we did some interactive demos for fun. So that's just a snippet of the things you could do with this. So yeah, if we want to pull the screen share down and answer some questions, and then I'll talk more about, again, our surprise, and then how to do more with this. Because this isn't just a one launchable that you can use. It's actually kind of a template you can take and customize. And we'll talk about that too.
Awesome. Okay. So we got this question from Paragon. I'll put it on the screen here. Will Isaac Lab implement PD auto tuning so that real log data would be put into Isaac Lab where parameters would be tuned with a log?
Let's see. Edmar, can you, let's see, pull my screen back. I lost my stream window. Here we go. Okay. Sorry about that.
Okay.
It went quiet and I got scared that I accidentally left the chat. Implement PD auto tuning so that real log data would be put into Isaac Lab where parameters tuned with the log. Maybe Rashad's got a better answer to this. I would say that like there are, different ways to model actuators in Isaac Lab. And
Yep.
I don't know how deep we want to get into that now, but
I know we've got tools for sure, even from like the sim side for physics inspection, articulation inspection, physics debug, and many of the other things like applying forces and understanding how like your joints behave. But I don't think we've got anything directly available right now for auto tuning. But we can certainly check and let you guys know if it's maybe on the roadmap, if it's something which is going to be coming up. But right now, as far as I know, I think like there are ways to tweak physics into your assets before you like start training and do stuff like that. but bringing in direct real world data and trying to convert it into simulation from the physics standpoint is not a feature we have as of yet. So, but that's certainly a good question.
Okay, great. Thank you for tackling that one. Here's a good question, I think. Probably a lot of people think of the same thing. How accurate is Isaac Sim for real world robotics, and how long does training usually take in simulation? So obviously that's not specific to Brev, but I'm sure some people watching this are curious, who maybe have not seen our office hours before. So you want to take this, Rishab or Shane?
I think Shane, do you want to take this? I think there's so many different layers for this question itself. Like you've got robots doing simple things like, for example, with the lay robot samples which we've already got, and then maybe on the other opposite end of the spectrum, you've got humanoids which could be like doing locomotion and manipulation. So the complexity for the robots and the tasks themselves in the environment change drastically. And that also plays a key role. But I'll let Shane get started here, and I can add in.
Yeah, sure. That's a huge question and a really good one, right? I would turn it around a bit and say something somebody said to me about simulation, which is, simulate what's important to you about a particular simulation. Like, is the contact behavior really important? Maybe you're just doing a digital twin where you want to check if these different assembly lines can fit in the same building, right? Like that's in simpler. Like you don't need accurate contact physics for that, right? You're more just like using a digital twin in a more fundamental way. So it really, I think it's I would turn it around and say, think about what's most important for your simulation and then focus on that, and maybe design your training to take advantage of that, or to be focused on those things that are most important for your robot. And as for how long does training take, I'm really trying to not say it depends, but it really depends. There are some benchmarks you can find, and Isaac Lab has a bunch of sample tasks. And man, some of them are really impressive in a few hours training, or even less, training like a locomotion policy for a quadruped. But again, it's like it really depends on the task.
Yeah, I think just adding a little more onto what Shane said over here is like, given that robotics, like you've got so many different embodiments, you've got different types of tasks and environments themselves. So, for example, where you've got maybe a manipulator, which could be like a Franca arm, which has got like maybe 6-7 degrees of freedom, for example, doing something like pick and place. So there's so much possible variation which could be in that same task itself. You could be like maybe picking up a cup, for example, which is going to be different than maybe picking up a pen. So for each of those tasks, from the robot standpoint, modeling the robot itself might be very similar, but from the interaction with the environment standpoint, where the robot needs to understand what sort of an object it is, how does it need to plan its motion around it, and how does it need to actually grasp the object, for example. And do you have real world data for this, or you're relying entirely on simulation? And are you mixing data? What sort of models you're using? So I think it's just a very broad problem to like just try and answer in a very straightforward way. But coming back to even what Shane said, in terms of a simple example, if you've looked at the Spot robot, for example, the quadruped from Boston Dynamics, where we're able to bring it into Isaac Sim first, make sure physics is set up as expected, and then train the robot to walk inside Isaac Lab. So barely a couple of hours on a single GPU, and then deployed zero shot into the real world as well. So actually taking that same policy for locomotion, basically the robot brain, and putting it onto a Jetson, onto the real Spot robot, and being able to make sure it walks around. So end to end, if you actually look, when you've solved the problem, like training itself probably just took a couple of hours, and deploying also probably took a couple of hours. So you might think it's a day's project, but even getting to the point where you're able to set up the robot, understand what are the training parameters, understand the models, the deployment, that process turns out to be experimental and iterative. So that is where like there is a lot of figuring out to do. But yeah, if it's a cliched answer, sorry, it's like dependent on the task, the robot, the complexity of the environment. But the important things which we've understood in general is like physics simulation plays a very crucial role in this whole process, as well as the fidelity of the environment from the photorealism standpoint, so that your models can actually understand what happens around them, and physics as well, because like your robot is operating in the real world. So as long as you're modeling those two things correctly, along with all the other uncertainties in your environment, you should be able to start making progress. So sorry, Adma, that was a super long answer.
No, that's great.
Oh, that's good. Good though. And I just add one minor thing to just looking at this question more, is that accuracy is one thing, right? You may also want more variety than you know about in the real world, right? Often these tasks in Isaac Lab will add some randomization into them.
Yep.
And that's an important part for making a robust policy. And there's trade-offs with that. And I'm going to stop it there so as to not make this a longer answer. But something to keep in mind is accuracy is one thing, and randomization is another important part.
We can have an office hours just on this
Yeah,
topic. Like
seriously.
it's
Oh,
that
probably
important.
should.
17 office hours. It's a huge topic.
I think we should. That was a great question. All right, Michael's got a great question coming in from LinkedIn. Put it on the screen for everybody. How easy is it to switch between Brev's launchable and the WebRTC version during dev?
Let me make sure I understand this. So the launchable is running, and let me just back up to explain a little bit more. So the launchable is running Isaac Lab. It's running a VS Code container, which is like our interface that we saw, and it's running a streaming client for Kit app streaming. So to switch between, so we are using WebRTC, like that's the streaming mechanism underneath Kit app streaming. So to switch to maybe let's say like a desktop version, like if you had a desktop app to switch to streaming, like it's the same tool. And I guess I need to know like a little more of the use case, but it's really using the same tools. It just has the convenience of figuring out the URL for you. And I'll say as another, just to give another example that might help explain that. One of our ambassadors, Michael Wagner, had a great tutorial recently on using Isaac Sim on Brev, and it doesn't use this launchable. So like, how does that work? Well, it's taking the container for Isaac Sim, similar like we have the Isaac Lab container here, which has Sim in it, but take the Isaac Sim one, put it in Brev and run it, and then you can access it through a local streaming client, which is also WebRTC. So same technology, just like a different packaging of it, we'll say. And the difference with this is you get Lab also, and you get this convenient streaming interface to be able to see the UI. But if you just need Isaac Sim and you're not using Lab and like starting and stopping Isaac Sim all the time, that's another option to use Brev. So again, we'll get more into like all the different ways you can use this. And guys, maybe, do you think we should show should we give away the surprise now and then get into more nerdy details?
Let's do it.
Sure,
Okay.
I already did it by accident twice.
For the astute viewers. So I guess I'll introduce it. Yeah.
Yeah, go ahead. Yep.
Okay, so we actually have Brev credits for people to try the Launchable out for a few hours for free.
Yeah, that's awesome.
So I don't know where our soundboard is. Edmar, did we get you a soundboard yet?
No, I
Dang it.
for it. But I think
next time.
do you want me to share the screen or?
Yeah, go ahead and share it. So we picked this number because our introductory Isaac Lab courses take a few hours. So this would basically give you compute to do one of these introductory courses for free. So step 6 is your screenshot. that's the code. And we actually have 1,000 spots. So I don't know how many people are viewing right now, but like everybody gets a live stream. Everybody gets a code, right? And so these are instructions for how to get the setup with Brev. I'll just walk through this really quickly. And I can, I guess, jump into the chat and let us know if you want to see me walk through all this. But it's really pretty straightforward. Basically, go to Brev, make an account. You need to make one more thing, which is an organization. So this is, if you're by yourself, congrats, you've got an organization. If you're working with a few people, this is people you can share these resources. Once you've created the organization, and this is a bit of a little quick to notice, it'll say undefined at the top right of the UI until you have an organization. So you choose your organization, then you go to billing, and under the billing tab, there's an option for redeem code, and this is your code.
Quick question, sorry, Shane. I think, are you sharing your screen by any chance?
I'm sharing.
Just talking through the slide.
I'm sharing the slide.
Okay, yeah, because I think he was walking through the steps. I was not sure I was able to follow along. So you want to share your screen while you do that, or?
No, to write this down. No, does everybody see the slide?
Yes, the slide's up.
Yeah.
Okay, great. Thank you, though. So then redeeming the code. So enter the code. It's OV-livestream-2025. And I would say, if you're going to deploy this, I'd say wait to deploy it unless you're going to try it out now, right? Because you get the credits. The launchable costs about $3.61 an hour to run. So get the most use out of it, right? And so don't deploy it until you're ready, but you can go ahead and redeem the credits at any time. Then you'll see at the top right of your screen that you have $10, which again, for this launchable is about 3 hours. So with that, and then of course the launchable, which is on our GitHub, github.com/isaac-sim/isaac-launchable, and you can search that too. I'm sure we'll put the link in the chat. So maybe now is a good time to talk about a little bit of best practices with Brev and like things to know as a dev.
Sounds good to me.
Okay, cool. So first of all is that it is pay by the hour, right? You're basically renting compute in the cloud. So if you've used cloud services before, this is no surprise. I'd imagine you're very familiar with this kind of model. If you're new to it, I would say it can be very easy to forget that it's running and burn through your credits. So you put credits in your account and those are what gets spent unless you specifically say auto renew. So that isn't the default. The default is use this much money, right? So I try to be really mindful of like when I use my instances, I'm sitting down to do a task, I'm developing, I'm letting the training happen. And then at the end of the day, I'm like shutting it down and coming back to it the next day. So up to you how you want to work with it. But I would just say be mindful of that. It is pay by the hour and it is like renting a GPU in a very hand wavy way, you could say that. So keep in mind that. Other thing is keep in mind you might need some download time or upload time. If you're moving assets in and out of your instance, whether it's from your local machine or like Rashad said, where you're taking something off of S3, or let's say you're pulling something from Hugging Face, let's say you're using a launchable to train Groot or to train Cosmos, you might need some time to move data in and out of your instance. So make sure to factor that in too. Lastly, I'd say instance availability. My experience on Brev has been the instances are largely available when I need them, but they are ultimately a limited resource. So there is always the chance that if you restart an instance, you might have to wait because it's not available. So with those caveats, maybe we'll take a break for a few questions and I'll explain some more ways to work with this that are more custom, the more ways you can take control of this and shape it to how you want to use it.
Those were great tips and guidance. Okay, so we have a good question here. How is a Brev different from having an AWS EC2 instance, which is, I think, included in our documentation?
Yeah, actually, Edmar, do you mind sharing my screen? And I've heard my screen is too small and I'm so sorry, and I will try to make it bigger. So let me actually just screen share this window and we'll make it better.
Lots of good comments here and celebrations over the credit. So,
all right, so
here we go.
Right.
We got you.
All right, so we're
much better. Much better.
Yeah, yay legibility. So this is actually running. If you look, where does it say it here? It doesn't say here. But if we look at the launchable, so if we go to our repo, the Isaac launchable repo, go to the Isaac launchable repo, we scroll down to the deploy button. You can see this is actually running on AWS. Yeah, there we go. It's like it says it here somewhere. Yeah. This is running on AWS. What I would say Brev is really good at is just making an easy interface for this. So if you wanted to launch a new instance, it gives you this really nice interface for picking, pick your compute, like a 6000 ADA or at H100 or H200, and seeing the cost per hour. You can customize the RAM. There's like lots of options available to you. So I think what Brev is really good at, it's not that it's different. It's like a layer on top of it that makes this so easy to set up. Again, with like a few clicks, you're up and running.
Yep. I think also one important point here is similar to what we discussed earlier. Like if you look at Isaac Sim's documentation for deploying on any of the CSPs, for example, like you do need to follow through all the steps. So I can quickly screen share and we'll be able to probably see the difference as well.
Sure.
Yeah, let me look for that. Just a sec. Oops, this was not the one.
And while Rashab's loading that, this was ready a while ago, but I'll show you. This is what it's the interface looks like when your launchable is live. And again, this took, I think it was about 7 minutes.
Oops. Oops, sorry,
yeah.
shit.
No, go ahead. Just saying it launched. And yeah, go ahead.
I think, in general, if you look at the documentation for Isaac Sim and any of the CSP deployments, for example, where you'll sort of understand what are the prerequisites and what sort of instance you need to select, what sort of steps you need to actually follow through. So for example, here you will need to pull in the Isaac Sim container, make sure all the dependencies before that is resolved. You would also need to make sure that you select the right types of instances, set up security, for example, over there, just go through that entire process, which is going to be CSP specific, because if you're deploying maybe on an AWS EC2 instance versus maybe on Azure or GCP, the steps are a little different here and there. But at a very high level, they do follow a basic functionality where it's like, make sure the prerequisites are set up, make sure you select the right hardware, and make sure you pull in the Docker container, and then you run it from there. So what Brev does here, is it basically abstracts away all of that for you. So like Shane showed us, it's basically like just 2 or 3 clicks, and all of this is going to be done in the back end for you with a CSP, which has already been configured over there. And that's going to make it really easy for you to get started. So there is a slight variation in the steps as well in terms of being able to see the WebRTC viewer directly showing up in your browser from the Brev standpoint versus maybe setting up a client locally. Or for example, if you're using AWS, you might be setting up like nice DCV so that you can have like the entire GUI visualized. So on each of the different CSPs, there are different visualization mechanisms as well to make sure that you can have your entire GUI being streamed onto your local PC, or it could also be the WebRTC client, which Omniverse provides. So there are multiple ways to go there. I think like Brev is going to provide you a simple way to get started where you don't need to worry about all of those things. So just a slight difference, but a different experience in terms of how you can work through the same issues.
Very cool. Great information. Okay. Someone. I see a bunch of questions here. I'm trying to look to see how to tackle them. Let's go. Based on the number of them, and we got about 20 minutes left, I'm going to say to Shane and Rishab, let's try to be as condensed as possible in our answer. And if there's something that's better for the office hours, just say office hours, or they can post that on Discord, because we have Discord channels that are set up for Isaac Sim and Isaac Lab. We also have an Isaac Sim and Isaac Lab study group, which actually takes place today, every Wednesday at 12:30 p.m. Pacific. So after this live stream, you can go to our Discord server, and the Isaac Sim and Isaac Lab group are. And then some of these questions don't relate to Brev at all. So I'm probably going to go quickly over those, but let's see how far we can get. All right, here's a question from Vector. I see there's someone very observed your robot arm. Is Isaac Sim Brev going to have a robot home environment as an intro for beginners?
Well, great eye, Vector. There are more over here too. There's other robot goodies off camera. I'll show another time. Has it been added, Rishab? I feel like.
I think it has, right? Like we've got the URDF as well, which can be like brought into Sim through USD. So once you have USD, you should be able to run Isaac Lab with it to set up environments and do tasks. So I would say yes.
Okay, cool. Here's a good question from our awesome Omniverse ambassador, Moromar Bay, aka Lychee AI. Are custom launchables shareable with everyone? It only shows mine, even in public.
Absolutely. So when you create a launchable, if you go to your page, gosh, we could almost show making one, but there's an option to set it from public or organization only.
Okay, there you go. Good question, Moromar. Thank you for that one. Okay. Here's a question from Tirth. What if we wanted to put our custom models and confidential company data on Brev? Is there any secure version of it?
That's a good question, and I don't think I'm the person to answer it. I think for more mission critical, like if you're already deep into working with Isaac Sim and Isaac Lab, this might not be the most useful option for you. Like you may want different controls over it, or to use the cloud in other ways, like Rishab showed, that ultimately give you more control. This is really about like being able to spin up an instance quickly and start testing. So I think there's maybe extra considerations if you're dealing with something that's really confidential, and like I'd be just hesitant to speak to how what the best practices are there, because I'm not a security expert. But
yeah, feel free.
Important concern.
Yeah, feel free to also post that question on our Discord server, and feel free to tag me. I can follow up with some other members of our team might be able to help give some insight there as well. But that is a great question. Okay, from Tom, aka Dylan, I know his real name. Can Brev hosted services secure APIs directly to clients, or should we always place an API gateway in front?
So there are a couple options. When you, let's see, let me
share your screen
again? Yeah, let me get this set.
You let me know when.
Yeah. Basically, there are some options to like, yeah, I'm ready, Admar. For example, to allow these only for your IP when you create these access, like when you open up these ports, like you can change who is accessible. There's also some other tools that might be good for this, but that's a quick one you can do. Like you could revoke and re-allow these, I believe. I haven't tested that. And then also the VS Code container too has some different mechanisms to like put a password in front of it. Again, not a security expert, putting my hands up there that you want to look into that deeper, but there are other ways to control that. I also want to quickly answer a question I saw in here while I'm here. Somebody launched their instance and they were like, how do I access VS Code? And I hadn't shown that part. So once you're launched, scroll down and this port 80 is going to be your VS Code. It'll take a little bit. We don't need to watch this in real time. And the default password, and gosh, you're really gonna know I'm not a security person now. The default password is password, and it's something that's really just there as you could customize that if you were setting this up more yourself. So now you have Isaac Lab. So I'll yield
the
next.
security people are going to run away when you say default password.
Might as well not be there. That is what that is. But. And then all of these steps, by the way, are in the repo. So if you go to that Isaac Lab, Isaac Launchable repo, the README has everything from creating your own Launchable based on the repo to everything we talked about today.
Awesome. Great. And I think, Shane, you actually noted this comment in our internal chat that you wanted to talk about from Michael.
Oh, yeah. This is a good question. Yeah, actually, perfect question, because I wanted to talk about other use cases for this. So let's start with Michael's question. So which version is better to use? And I'm going to take that, if hopefully I'm understanding right, is like, do I use Brev, Isaac Lab, or Isaac Sim, or do I use local? Well, the launchables are a really convenient way to spin up maybe more compute than you have locally. Like if you want to work on an H100, you could make a different launchable, like for training Groot, let's say, post-training Groot, and spin up an H100 and do some work with that. And have it for a few hours, and then shut it down and walk away, and get your data off of it, and then be done. So yeah, rapid prototyping is a good example. I think also for learners starting out, you don't have to go through the Isaac Lab install steps. You can just start with this. Resource intensive, yeah. If you need more compute, this is an easy way to have it pretty quickly. And collaborative debugging, well, you can't share the KitApp streaming client with multiple people. You can only have one of those. You could both look, I think you can both look at the VS Code instance, or you could at least share it with people in your org. So yeah, there's a couple different options. And just to expand on that, so learning, we mentioned scaling up, like I need to do this one thing that requires an expensive GPU, and I just need it to try something out, or like I want to evaluate a new model. This is kind of what Brev was created for, is like to enable AI developers to be able to do things like that. And then let's see, hackathons are another big one, or any time where you want to give everyone like the same resources or starting point. So you could say like, we've got this repo clone built, ready to go. Everyone's going to use an L40S, level playing field, or however you want to do it. But it's an easy way to say, here's this environment. Or like in our case, maybe it's a course and we have assets in it. We have things pre-built for you. That's what I'm really excited about, is to be able to hand somebody something that's kind of ready to take a course from. Or to just say, if you don't have a GPU yet, here you go, try this out. You don't have to get your company to buy you one yet. Just to evaluate this, you can start going and then get enthusiasm about it through a different way. So long answer, but hope that helps.
Yeah, I think it helps a lot. It's great. Okay. Very good one. Here's another one. This is more of an Isaac Sim question, but I'll show it on screen. How do you model and simulate sensor noise corruptions in Isaac Sim? What kind of sensor artifacts most harmful in real deployment? We could, if you have a quick answer for this and others, we'll direct people to the Isaac Sim channel on Discord.
I can take it. We do have like a quick answer to this. So in general, from the post-processing side for sensors, for example, like cameras, lidars and stuff, you can get like the data directly through replicator, and you can add like Warp kernels, or you can have your own custom NumPy arrays as well, which can distort and add noise, Gaussian noise, and different types of noises as well. So that can really help from the simulation standpoint to add more randomizations in. And most harmful sensor artifacts and real deployment is a very open-ended question, because you would want to model different types of camera models, for example, intrinsic, extrinsic, LiDAR firing patterns. So that's very broad, but there are a lot of things which are supported directly in Isaac Sim sensors today.
And
Okay,
Isaac
great.
Lab has some basic means to add corruption to different actions and things, right?
Very cool. This is a quick question, because we mentioned this earlier. Someone was asking about the link for the Discord group. So what you want to do, if you're not a member of our Discord, just join. It's very easy. I'm going to post the link on the screen. I apologize for this graphic, as I always do when I show it, because it is really big. Sorry, Shane.
Yeah, I felt that. It's like a cold wind.
So go there. You could go to our Discord server, and then you're going to see a bunch of channels on the left. The channels are grouped into categories. We have a category called study groups, and in that study group, you're going to see Isaac Sim and Isaac Lab. If you have any problems, feel free to let us know in the chat if you're having difficulty. But super easy, and they're also on our add event calendar with more information. Our producer will put that link in the chat so you can see all the upcoming live streams and office hours. But great question, though. So thank you for that. Okay, let's see what else we got here. John has another question here. Can I tweak the Omniverse version by doing some TOML stuff? Yes. Amazing. Mm-hmm. Okay, good. There you go. So have fun.
Briefest answer yet.
This is also a general question regarding Isaac. Well, is thermal imagery possibility?
Not as of today. I'm not sure even if it's like that. That's on the roadmap. We might know, but not right now.
Okay, thanks for that. Let me see. Here's another question from YouTube. Is it easy to implement something simpler as a motor and actuator in Isaac Sim? What are the criteria to bring that simulation? Is it just SDP file?
If you're I guess it depends how accurately you want to model your motor. If you want again, let's say a basic digital twin, you've got a motor model and you want to see the shaft moving based on data from like MQTT or a PLC you connected or some simulation data you have recorded, like setting that up with physics and rigging it to move is, I would say, fairly easy to implement. If you want, the closer you want to get to modeling the actual characteristics of a motor, the more interesting and difficult it becomes. But important question to answer.
Fair enough. And I think also it depends, right? If you are just trying to model a joint of the robot itself, then we already have like solutions which do exist to debug physics and set up things there. So it really depends what sort of level of granularity you're looking at for motor simulation here.
Okay, great. Let me see. Oh, here's a great question.
Fire questions, Edmar.
I know, a bunch. We have to go quickly now. Okay, here's one from YouTube. Is it possible to simulate some of the Isaac manipulator workflows in Brev that are traditionally run on Jetson?
I can take that, Shane, quickly.
Yeah.
So I think like you already have access. So Brev is basically just giving you access to an instance, right? So you've got access to an instance which has got all the hardware set up for you. If you want to run Isaac manipulator workflows, you probably need to clone in the Isaac ROS Docker container as well, which is going to be responsible for the ROS interconnectivity between sim and manipulator. And Isaac manipulator already has examples with Isaac sim, so you can run them off the bat. So you can do software in the loop initially with sim and ROS on the same Brev instance. And then if you actually move on to hardware in the loop and real world deployment, you can touch on Jetson. So answer is yes, you can do it.
Amazing.
I'll say I haven't tested any ROS workflows with the Launchable yet. So there may be a little work needed to make that work that I don't know about.
Yeah, I'm not too worried about that, because like even in general cloud CSPs, like when you do have Docker containers running, as long as like they're able to see each other and ROS is able to find them, so you've got like some environment variables you need to set up, but it usually works.
Sure. Oh, this is a good question.
Yes, I think we kind of showed this briefly, but if you want to talk about this.
Yeah, this would be an important one to talk about. So actually, if I have just a minute to show about how you can create your own Launchable, again, I'll really point to, if we can share the link to the repo, the instructions are in there on how to create your own Launchable. So I won't walk through it step by step, but this Launchable, kind of like the Kit app template and a lot of other tools we make, this is like an example, and you can use this one and build off of it, or you can make your own. So the repo and all the instructions to make the Launchable we link to are available to you. Now, this means you can choose your own compute. And we haven't tested all the compute available in Brev because there are quite a few. And some of them are GPUs that aren't compatible with IsaacSim or like for most people's way they work with IsaacSim, for example. So we've tested L40Ss on AWS. I also know that we had issues with the Crusoe deployments we tried. There was like the KidApp streaming wasn't working, and I'm not sure why or like where the problem was. So we just like haven't supported it or encouraged people to try that one yet. But we might figure that out soon. So we basically have this one we've tested, like this L40S on AWS works well. But if you want to try your own, I've tried like more performant AWS instances of L40Ss, and those work too. I've tried H100s for Groot. So like there are different, you can choose different ones, but we haven't tested all of them. There are a lot, and this is a very new project. So as for what GPUs are supported, I would first look to the IsaacSim docs, which tell you what GPUs work with IsaacSim, then go see which ones are on Brev. So sorry, I know like a more obvious answer like here are your 4, but there's a lot of options.
Oh, great. Thank you for covering that. Okay, here we go. The AWS solution of IsaacSim creates a full Ubuntu virtual machine. Does NVIDIA Brev only run a VS Code instance? If so, how are the projects managed and stored in Brev?
Well, I think it's an Ubuntu container. But it's VS. Yeah, the containers we have is VS Code and Isaac Lab and the web client for KidApp streaming. So
Right, also, Shane, I think like it is still at the back end running on an EC2 instance, right? Which is at least in this case. So for regards to this question is like you do get access to a full Ubuntu virtual machine. The ones which we actually showcased in terms of using with Brev is mainly interacting with it through the VS Code side so that you can set up your project and being able to visualize KidApp streaming. But you do get access to an EC2 instance because you can clone things, you can pull things, you can build things over there. Everything's possible.
Yeah, actually from that console page I showed earlier with the link to the VS Code instance, you can use Brev to like SSH into the Ubuntu machine. Sorry,
exactly.
I'm blanking on that. So yeah, you get access,
Right.
and that's useful for troubleshooting if you need to take the containers down and bring them back up, but you get SSH access to it.
Very cool. I just pasted a link to a thread that we started on the Discord server specific to this live stream. So any questions we don't get to, head over to that link I just posted in the chat, or just go to the Discord server at your own time and go to this section for developer tools and resources. That's where we have all these live streams. And then you'll see a thread there I started with some of the links. Actually, one of our community members, Zia Ideas, actually asked a good question here in that thread. Let me read it out loud. Wondering, can we use Omni's Nucleus server if we are all deployed on the same page via Brev?
That's interesting. I don't know if I have a good answer for that.
So the great thing is that because this is on Discord, we can actually respond to Zia afterwards.
Yeah, interesting question.
Yeah, it's a great question, though, Zia. Wow. Okay. As I was saying that, somebody just posted a new question there. Let me see if I can. How does Brev handle access in the same instance from different IP addresses? For example, in AWS, we have to update security settings and add a new IP to gain access. How is this managed in Brev?
So I'm not an expert on this, but what I see is the default is it allows for any IP, and then you can choose to limit it to just your IP. So I think it defaults to more open, but if you want, you could reconfigure those ports to be just your IP. That's my understanding.
Okay, cool. All right, I'm going to put this on the screen again. This is the code here for the credits, and hopefully everyone who's watching will be able to leverage this for a few hours, which is just enough time to get going and have some fun. Here's a question from Dylan again. How does Brev provide built-in auto-scaling? Is that something that's possible?
Auto-scaling in terms of like bringing in more GPUs?
I guess, based on the project, maybe? I don't know.
Yeah, if it's in terms of compute, you kind of set with the compute you configure. You might be able to change it manually, but I don't think it automatically can scale. I might be wrong on that, but.
All right. Well, here's a question that I can even handle. Is this session going to be recorded? So all of our live streams are absolutely on our YouTube channel. Just go to live, and then you'll see all the live streams, the office hours, Rishab, and other live streams with Shane, other members of the team. They're all there from the past. So you can watch them at your convenience anytime, including this one. This one will be available at the same YouTube link. You may be watching it right now, right afterwards. Okay. How scalable, I guess is a similar question, but how scalable is Isaac Lab and Brev for multi-robot reinforcement learning experiments?
Scalable in terms of the task training, or scalable in terms of like the compute you need? Because if it's the compute you need, I think that goes back to the last question of like, yes, you can in theory choose bigger compute to handle a more involved task.
Okay, cool.
Hopefully that helps.
All right, let me see. Here's a question coming from YouTube. My session is built, so how can I access it in the web?
Yeah, so I think I showed that earlier, but just let's show it really quick. You scroll down, or I'll just talk through it. Once you're on the Brev console page for your instance, if you scroll down under using ports, there's a link to the port AD link is the VS Code instance. And again, if you forget this or you come back to it later, the GitHub README has all of this written down for you. Walks through every step.
Okay, great. And Shane just gave me a nice reminder that the time you have, I was going to paste this from Shane in the chat, the time you have should be enough. I'll put it on screen too. Should be enough to do our Isaac Lab courses here. So you can always search for Learning Path Robotics in your search engine of choice, and this should come up right away. But these few hours you get here should be enough for that, which is amazing.
Yeah, and I would just say read through the course, get familiar with the content, and then fire up your instance to make the best use of your credits. But the train your first, train your second robot courses, this should be enough to do at least one of them. So hopefully that's a good way to kind of kickstart or like make the most out of that free time you have. And please share that code with your team, your friends. Like we have, like I said, 1,000 spots, so please use it.
Okay, cool. Question from YouTube: What all Isaac Sim versions can you get on Brev, or is it just 5.0?
Just 5 right now.
Okay, there you go. It's a quick one. Okay, does Isaac Sim Lab support differential simulation for gradient-based training? If not, are there plans to integrate differentiable physics in future releases? That's a deep dive question. I don't know who has the answer to that one.
That is a Warp answer. So I think, just looking at the Warp office as is going to provide some more perspective as well. But I think with potential hints about like Newton integration and stuff like that in the future, that is upcoming. So we'll have more information once we've got those releases out here.
Great. And speaking of Warp, we're going to cover something on Warp today. No, I saw that in the ad event. So that might have been a typo from someone on our team, but I didn't know if we were going to share something on Warp. But
we just did.
That's true. If you happen to be here because of something we mentioned about Warp, then I apologize, and we will. We have a Warp channel on our Discord server also, so feel free to ask any Warp related question there. I know our Warp team actually is amazing for the community. They've been very actively engaged. So post your question there. Okay, here's a question from Omniverse Ambassador Scott Dempsey, aka Sirens. Can we just port extensions over, or do we need to make a container and send them to Brev?
I mean, if you're talking about like an Omniverse extension, you can bring that in, like drag drop it to download it, and then put it in the right folder, link it in the TOML files or whatever. Like you can set it up and just use it like another computer.
Cool.
If you have something that is containerized, you could also bring that container up in your Brev instance, but that'd be like a little more setup, right?
Yep.
Okay, cool. Let me see. We're almost done. I know we're running a little bit over, but this is so fun. We've got a question from YouTube. Are the Isaac Sim Brev runtimes able to be integrated as part of another product, or is it via some sort of NVIDIA console specifically?
I mean, a lot of this is all built on tools that are all fairly accessible through other means, right? Like we're using the Isaac Lab container, we're using, the streaming, the web viewer sample is what the client is based on. We're using the VS Code container. Like these are all fairly available module standard things that use Docker, use SSH into your instance. Like there's not a lot of like, when you say Brev runtime, like Brev is really, I think of it more just a means to get easy access to cloud resources. So to that point, like you can take this whole repo, clone it, and if you have a GPU that can run Isaac Sim locally, you can actually use this as like a local install just by bringing up the containers and accessing it all locally. So that's another secret of this, is it's also just a quick local install. So integrated as part of another product, I mean, yeah, it's all in Docker. Like, depending on what you're trying to do, it could be really easy.
Okay, similar kind of question here from YouTube. Is multi-container orchestration possible with Brev?
Yeah, we've got this example is 3 containers.
Perfect. Okay, great. That's a quick one. Okay, I think those are the ones that are really specific to Brev. I know we're over time, so I want to be sensitive to Rishab and Shane here. If you have a couple more minutes, we could try to tackle a few more, the more general questions. Up to you guys.
Sure.
Okay. Cool. All right, here we go. Here's one from YouTube. What strategies are most effective in reducing the sim to real gap when deploying Isaac Sim trained models on hardware? Shane's already laughing.
Oh, I just like this is hard to answer in a short way.
Actually, I think it is similar to what we even had earlier, like different robots, different embodiments, different sensors. I think it's a very broad topic to like get into. So
Yeah,
there's
some of
various
these
strategies.
some of these questions are actually fantastic to ask on the Discord server, because then other community members can come in and chime in and share different case uses. So some of these questions are really good for the Discord. I will say also there's another popular group that's been more and more active recently on LinkedIn. So if you go to LinkedIn and search for NVIDIA Omniverse, we have a group there. And I've noted a lot of the people joining lately are robotics folks, engineers. So I would invite you to search for LinkedIn. Search for NVIDIA Omniverse on LinkedIn. You'll see a group. Feel free to join that. I'll approve your request pretty quickly. And then you're going to be part of the 2,000 plus people that are there. That's another great resource in addition to the Discord server we mentioned earlier. Okay, let's see if this is a general question from a great community member, actually, who's a regular viewer.
Yeah. Shout out to Idamar. Sorry if I'm saying your name correctly or not correctly, but one of the first people to post that they had tried this out and shown it to some of their students, and that was really fun to see. So shout out.
Yes. And I believe she's a professor, I believe, if I remember correctly, in Brazil.
Yeah. It was really fun to see that. So I don't know what's coming out. I don't know if I could say, but I do. We actually just released an Isaac for Healthcare course, and this could be like a good candidate for that. So I don't have specifics, but I think this would be a great combo.
Yeah, that's great. Okay, cool. Okay, here's a question from LinkedIn from Carolina. Can I run a VLA simulation on Omniverse? Why not? I don't know.
Which one? I'm not sure.
I think the shortest answer is yes.
Like,
probably
Okay.
which model it's going to be. Is it going to be containerized? Like there are a lot of questions, but you should be able to like get access to camera stream from OV or Isaac Sim and then run your VLA models there. So
yeah, I guess I'd say with a lot of these questions, think about Brev less as like a new special different thing and more of a way to get easy access to compute on the cloud. So you can use a lot of these same means, right? Like containerization and streaming and like all these different tools can just be used in the cloud really easily. So it's less about like what's compatible with Brev or not. It's more like what's compatible with the GPUs on Brev and that sort of thing.
Okay, very cool. All right, so let me see. I think we're only down to a few more questions here. This is amazing. Okay, let me look for. How about this one? I'm not familiar with these, so maybe you guys can.
Yep, sure. I think Gazebo and Copilia Sim, like just mentioned, primarily based on C++. So for Isaac Sim, for example, mainly you've got like the Python interface as well to interact with the simulation, but you can also have like a C++ interface as well. So for example, you could write your own extension, which has got like a combination of Python and C++ code, combine it, and then you should be able to like bring in your own OmniGraph nodes and interact with simulation. So possible to use both Python and C++. And for force control, again, that's a physics thing. So we've got a lot of tools over there which will help you understand how you want to modify behavior as per your expectations when you do have like force, torque control and stuff like that. So we've got tools for that. So Python, C++ both possible, and we've got tools for force control too. So it should not be too complex. If you can do C++, Python usually turns out to be easier.
And if you know those other tools, I feel like you could likely pick up Isaac Sim pretty quickly.
Yeah, pretty quickly because you understand the basics.
Yeah.
Look at this great comment we're getting. Session is amazing. Thank you so much from nearly neuromorphic Nick. I'm just curious. I'm gonna put this on the screen because I just don't know how it's going to display. I'm just totally curious. Let me see. There you go. Thank you, Nima. Okay, we covered. Yes, this recording can be available afterwards. I mean, we might have gone over all the questions. I don't know if we covered this one. Is a Docker image running for the Isaac image since the same one through NGC? It is. Okay.
Yes. And if you look at the repo, you'll see that in one of the Docker files. You'll see it's pulling that.
Definitely check that repo. If you missed it, we post it in the chat. We'll add to the description afterwards. Rodrigo asked this early on, and I wasn't sure about this one. Is it possibly VR deployable apps? I'm not sure.
I guess deployable on Brev or just deployable in general? Because like we had a great course on doing a VR app with Omniverse that we did at GTC San Jose and at SIGGRAPH. It was like a few different experiences with digital twins in VR. So on Brev, like I guess it would depend a little bit on. I haven't tried that yet, so I don't have specifics. But in general, deployable apps with Omniverse, yeah, there's a lot of infrastructure for VR and a lot of cool projects you can do with that.
Okay, very cool. I actually think that we have covered nearly. Oh wait, here's one that just came in. YouTube. Is there a way to use RGB cam to scan and run depth estimation and create the same environment in Omniverse?
I would say this is probably a question which is more tailored for NuRec, which is one of the newer products we have, which also integrates into IsaacSim and Omniverse in general. So bringing in your own camera, scanning images from a couple of perspectives, making sure you've got some sort of an overlap between features will allow you to like bring in that same asset once you've trained a model into IsaacSim and USD. So we probably will have a deeper dive session for that maybe later, but yes, this is possible today. Okay,
cool. We have a good question on minimum requirements from Lethal Toxin here. Can IsaacSim run with the RTX 3060 and 32 gigs of RAM? So obviously the recommended ones are for the best experience. So if you use something lower, just be ready for less of an ideal experience, but you can always give it a go, and it really depends on what you're doing. But yeah, I would say you can definitely give it a try. Okay. Here's one about physical AI. Hey guys, getting into physical AI, wondering about the importance of the teleoperation data compared to synthetic data. Is it possible to say that we need teleop data to have synthetic data? I guess it's a workflow kind of.
Well, I would say like if you've seen some of the work with Groot, for example, a lot of what one thing that Groot can do really well is take a small number of demonstrations of teleop and scale it way up. So in that instance, like the teleop data is used to make synthetic data. I don't know that that's, I hesitate to say that like you have to have it to make it, because I think there's other ways of generating that data that we're finding. But that is one way like of scaling up, because obviously teleop data is expensive to gather.
Perfect. Okay. Well, I think you guys have been troopers. We're way over today. So I want to thank our very special guests, Rishab and Shane, for coming on today. Clearly, by all the comments, a lot of excitement and interest in leveraging this. The discussion does not stop when the live stream stops. You can watch the replay of this on our YouTube channel. You can come discuss it in the Discord server. IsaacSim support is available on the Omniverse forums, so go there. If you need help with Isaac Lab, you have to go to the GitHub discussion area or issues area. And absolutely feel free to leverage the LinkedIn group that's on the NVIDIA Omniverse LinkedIn group, also to chat with other people in the community. Really fantastic time. I'm going to let Shane and Rishab go now. I'm going to spend a few more minutes for anyone who wants to hang out, and just going to go over a couple quick announcements from GTC. But Shane and Rishab, thank you so much.
Thanks for having us, Edma. Thanks for joining, Shane.
Thanks. See you.
Okay, so let me get my big head off the screen here. We're going to go over some really quick announcements. Like I promised in the beginning, we wanted to not take away time from today's presentation, but we definitely have some important stuff to share for those who are still hanging out. These are our hardcore loyal viewers, I'm sure. So if you like this, first of all, if you like this kind of information that we present in today's live stream with Shane and Rishab, please like and subscribe to this channel. It is super helpful for us as a team to know exactly what's important for the viewers out there. So let us know if this was valuable by liking and subscribing. And thank you in advance for that. Speaking of helpful discussions and networking and projects, GTC is coming up at the end of October. And for the first time, we're coming to Washington, D.C. So for folks who have the ability to travel to Washington, D.C. or live in the area, I would love to see you there. I will be there, and I'd love to have a coffee with you. We actually have a WhatsApp group that we've set up for people who are going to be attending on site. So feel free to let us know in the GTC channel we have on our Discord server if you're going, or reach out to me on my LinkedIn page. Just go to edmar.net and it should bring you right there. And then we have this QR code on the screen, which will tell you all about GTC DC, from the amazing keynote that Jensen's giving for the first time in Washington, D.C., super exciting, to all the sessions that we've got and other activities. We've got a lot of great stuff happening. And I can't tell you how valuable events like GTC are for developers and for businesses, not only to learn from experts, not just from NVIDIA, but from other great companies in the world, leveraging the technology, but also to the opportunity to meet developers like you, meeting each other. I can't tell you how many times I've seen different members of the community connect for the first time at an event like GTC, and magical things happen afterwards. There's this great synergy, great opportunity to meet those people that you really can help each other and bring your business to the next level. So networking is a big part of events like GTC. I hope you can make it. If you can't make it, that keynote I mentioned from Jensen is available globally. So you can watch that in the comfort of your own office or home. And that's going to be at October 28th at 10:30 a.m. Eastern. Okay, so a little early if you're in the West Coast, but not too early. So grab a cup of coffee and watch that with us. We'll probably do a watch party. The community usually does one on Discord server if you want to hang out and watch with other people. The team also asked me to remind everybody that if you are leveraging the physical AI data set that's on Hugging Face, we would love to learn about your project and to see how it's benefited. What has it helped you solve or got done quicker? We want to tell these stories at an upcoming event. And so you leverage that QR code to get to that page. If you need help, again, reach out to me with the ways I mentioned earlier, either through Discord or LinkedIn. I'm glad to help you. And I'm also super excited to share that all the SIGGRAPH sessions that just wrapped up recently are now available on demand. So OpenUSD Day was full of great topics and conversation and presentations, and you can access those by leveraging that QR code on the screen. Again, if you have problems with that QR code, just ping us. We'll be glad to help you either on Discord server or on LinkedIn. And then finally, for all of our resources and how we can connect, we have our Add Event page, which is that first link there. That lists all the upcoming live streams, the office hours, the study groups, the keynotes, all the important stuff that we think would be good to add to your calendar. And then we have obviously our forums, which we ask people to use for official support so we can track your request and assign the right people. We have our Discord server, which we've talked about a couple times. And then we have our community page at the end there, which is where we list our ambassadors. So amazing ambassadors across the gamut, many of which have great experience in the topics we discussed today. And you saw some of them interact on a live stream a few minutes ago. So come over to our community page if you want to find out all the greatest resources. And we also will be announcing our next round of our ambassadors at GTC DC. Those things are getting locked in right now. I'm super excited about the next group of developers we have that are joining our existing ambassadors. And if you feel like you have what it takes to be an ambassador and you are an expert in one or more areas of Omniverse, reach out to me. I'll get a questionnaire going for you, and we can talk about it and see if you're the right fit. But we love to acknowledge and celebrate the people around the world who are sharing their knowledge with others and can be a great member of the community and our ambassador team. That's just about it. Again, if you are a startup, I highly recommend check out the NVIDIA's Inception program. Sumay was on the stream a little earlier talking about that great contest. So feel free to rewind the stream if you want to find out about that. But if you're a startup business, Inception offers lots of great free benefits, including ability to network with investors. But also you have free cloud credits are available, no strings attached. Inception is just an amazing program. Maybe I love it so much. Maybe I'll play a little video about Inception as we close things out. It's been an honor to be with you all today. Thank you so much for joining. I hope to see you on the Discord server. And until next time, have a great rest of the night.
NVIDIA Inception is partnering with thousands of the world's most innovative companies, startups at the forefront of AI, data science, gaming, and other breakthrough industries. NVIDIA Inception is the free program that empowers startups through every stage of their life cycle. Learn how you can fast-track your path to success with these program benefits. Accelerate your growth with credits for technical training, online forums, and expert guidance. Jumpstart your development in the cloud, on-prem, and at the edge with over 150 NVIDIA SDKs, pre-trained models, cloud credits, and preferred hardware pricing. Explore funding opportunities and introductions through the NVIDIA Inception VC Alliance, a community of investors excited to connect with you. Strengthen your startup's visibility through exclusive events, speaking opportunities, and promotional support.
NVIDIA seems to be one of the few, if only, companies building a robust startup program.
No matter what your size or funding stage, NVIDIA Inception can accelerate your growth. Join our global community of innovators today to see what's possible.
Look at that. I'm still here. I want to remind you once again, don't forget to hit that like and subscribe, and we'll see